Okay, so we are going to be solving multi-step equations for a single variable. For number one, our first step is to distribute the 6 to the inside of the parentheses, to the expression on the inside of the parentheses. So we will distribute that 6 to the x and the negative 1. That will leave us with 6x minus 6 equals 30. Our next step is to add 6 to both sides. We'll get 6x equals 36. I can divide both sides by 6 at this point, and my answer is x equals 6. For number 2, again, our second step is to distribute the negative 3 on the outside of the parentheses to the expression on the inside of the parentheses. So I will distribute the negative 3 to the x and to the 4. That will give me negative 3x minus 12 equals 21. At this point, I'll add my constant 12 to both sides. I'll add a 12 to both sides. That will give me negative 3x equals 33. And if I divide both sides by negative 3, that will give me an x value of negative 11. For number 3, our first step for number 3 is to combine like terms. As you can see, we have two variable terms on the left-hand side of this equation, a 2x and a negative 3x. When I combine those together, that will leave me with negative 1x plus 4 equals negative 11. At this point, I want to take that positive 4 and subtract 4 from both sides. That will give me a negative 1x equals negative 15. Dividing both sides by negative 1, and that will give me x equals 15. Now, it's important to note up here in this step, we could actually also write 2x minus 3x as simply negative x. So that could be negative x plus 4 equals negative 11. Again, if I subtracted 4 from both sides, that would give me negative x equals negative 15. And this time, if I divide both sides by a negative, that's going to give me x equals 15. So again, sometimes your teacher may write it using a negative 1. Most teachers will not. They will just write it as negative x, but please understand that they mean the same thing. Number 4, it's a problem similar to number 3. As you can see, we have a 7x and a 2x, so my first step will be to combine like terms. 7 plus 2 is 9. So that will leave us with 9x minus 10 equals 15. If I add 10 to both sides, that will give me 9x equals 25. At this point, I want to undo the multiplication in this equation, so I will divide both sides by 9. 9 does not go into 25 evenly, so we can write this a couple ways. We can write this as just leaving it as the fraction 25/9, or we could write it as 9 goes into 25 2 times with a remainder of 7, so we could write it as 2 7/9. Either one of those would be appropriate. Number 5. We could do this a couple of ways, and I'll do them both here. We could actually distribute this negative 1/2 through the parentheses, giving me negative 1/2 x. And then the negative times the negative would give me a positive, and then 1/2 times 4 is 2. So that would equal negative 18. If I subtract 2 from both sides, that would give me negative 1/2 x equals negative 20. And it's at this point where we do not want to divide by a fraction. It's just best practice to multiply by the reciprocal. The reciprocal of a fraction is simply its flip. So we would multiply this by negative 2 over 1, which, when you just stop and think about it, is the same thing as negative 2. So I will multiply both sides by negative 2. The reason we want to multiply by the reciprocal is that this will automatically just cancel out. And I'll be left with x equals 40. Because negative 2 times negative 20 is positive 40. The other way that we could do this problem is we could get rid of the fraction right at the beginning of the problem. So what I'll do is I can simply, at the very beginning of the problem, multiply everything by the reciprocal of negative 1/2, which again is negative 2. That will cancel out the fraction. I'll be left with the parentheses, x minus 4 equals negative 18 times negative 2 is positive 36. When I add 4 to both sides, that would give me x equals 40. Number 6. Again, I'm free to distribute the 2/3 inside of the parentheses, but as you can see, 2/3 times 11 is going to give us an awfully confusing number to work with. We could still do it if we'd like, but just like that last problem, what I'm going to do is I'm going to go ahead and I'm going to multiply both sides by the reciprocal of my fraction at the beginning so that I can just get rid of it and not even worry about it. So what I'll do is I will multiply the left-hand side by 3/2, and as you can see, those will cross-cancel. I'll multiply the right-hand side by 3/2, and this cross-cancellation right here, 2 goes into both 2 and 16, so this would become an 8, and the 2 would simply become a 1. That means that I'm going to have negative 8 times 3, which is negative 24. And again, I'll just be left with whatever's inside of the parentheses on the left-hand side, because by multiplying by the reciprocal, I've cross-canceled my fraction. If I subtract 11 at this point, I'll be left with x equals negative 35. For number 7, here you can see we've got a variable term on the left, a constant term on the left, and on the right-hand side we have a variable term on the right and a constant term on the right. What I'd like to do is move all of my variables to the left, which means I will have to subtract negative 6x from both sides, causing those to cross-cancel. And then moving my constant term, the positive 6, to the right, I would have to subtract 6 from both sides, causing that to cancel. That's going to leave me with negative 2x on the left-hand side of the equation and negative 26 on the right-hand side of the equation. So if I divide both sides by negative 2, I'll get x equals negative 13. For number 8, again, it's a problem very similar to the problem on the previous page. I've got a variable on the right-hand side that I would like to move to the left-hand side because I move variables to the left. You don't have to, it's just what I prefer to do. And I have a constant 10 here that I will subtract from both sides. Sometimes your teacher will do these in separate steps. I just do them at once. That will leave me with 25x on the left. 10x plus 15x is 25x. That will leave me with 85 minus 10 is 75 on the right. If I divide both sides by 25, that will leave me with 75 divided by 25, which is 3. Here we have multiple steps that we can do. The first thing, whenever I see parentheses, the very first thing I like to do is distribute whatever's on the outside through the parentheses. That's going to leave me with, right here is my distribution that needs to take place. That's going to leave me with 2x plus 6 minus 4 equals negative 2x plus 10. At this point, now what you see is I've got two constant terms on the left-hand side of the equation. 6 minus 4 is 2. So all I did to get from this step down to here is I combined the 6 and the negative 4 to positive 2. That will leave me with negative 2x plus 10 on the right-hand side because I've done nothing to change it. And at this point right here, we have problems very similar to problems 7 and 8. We have variable constant on the left, a variable and a constant on the right. So I will move my variable terms to the left by adding 2x to both sides because it's the opposite of the negative 2x that's already on the right. and I will subtract 2 from both sides, and that will leave me with 2x plus 2x is 4x, and 10 minus 2 is 8. Divide both sides by 4, and I will get x equals 2. Number 10. It's a problem very similar to number 9. If I take the 6 and I distribute it through the parentheses, that would leave me with 6x plus 48 minus 6 equals negative 6x plus 54. 48 minus 6 is 42, so again we will combine the constant terms that are on the left. That would be 6x plus 42 equals negative 6x plus 54. Adding 6x to both sides, and then subtracting 42 from both sides. Again, I'm moving my variable terms to the left and my constant terms to the right. So that would give me 12x equals, the 42's cancel, the 6x's cancel. 54 minus 42 is 12. If I divide both sides by 12, that gives me an x value of 1.